This problem requires the understanding of Kirchhoff's law, the junction rule and the loop rule or the voltage rule. Using the Kirchhoff's law, we're going to solve this problem. So if you have not understand, if you do not have the background about the Kirchhoff's law, uh, please go through the book, and I'll also try to explain here, and it will be a little easier for you. Okay, so now let's start solving this problem. Before, you see, we have two loops here. This is one loop, and this is the second loop here. So what does the Kirchhoff's law tell you? You can choose the loop direction in any way you like. You can choose as a clockwise, or you can choose anti-clockwise. I'm simply choosing the clockwise. You can choose any direction. Okay. Now, and then the next step is you can assume the direction of the current. Here I'm assuming the current is this direction, I2, and this is I1. I call this an I1, and I can call this is an I3. I3 or this is I3 is the same thing. The current goes through here, so this is I1, I2, and I3. And if I look at this point here, just junction here, what the Kirchhoff's law tell you, it's not very clear into the video, so this is I1. Okay. So what does the Kirchhoff's law tell you? At any junction, the total incoming current must be equal to the total outgoing current. So these two, so you see this is incoming current, and I2 and I1 is the outgoing the current. So what I can write down from the Kirchhoff's law is I3, which is the incoming current, is equal to the outgoing current, which is equal to I1 plus I2. Right? So this is the incoming current and this is outgoing current. Alright? Okay. So now, so let's assume this is equation 1. Okay. Now come back to this loop here. I call this a loop 1. Loop 1. First, what is the loop 1 here? Loop 1. What does the Kirchhoff's law tell you? That the total voltage in any closed loop is equal to 0. So here, if you look, the loop direction for this battery is from negative to positive. If the loop direction is from negative to positive, we call that as a positive the volt. We simply call the 10 volt here. And now, so let's come back here at this point. For this resistor, the loop direction and the current direction are opposite. If they are opposite, we again use as a positive. If they are opposite, and the potential across this one is I2 times R2. We call I2 multiplied by R2. For this loop here now, at this loop, you see the loop direction and the current direction are parallel in the same direction. If they are in the same direction, you have to choose the negative, which is equal to I1 times R1. This must be equal to the 0. This is Kirchhoff's second law, and this is Kirchhoff's first law. Alright? Okay. Let's call this as a number 2. Okay. Now we can loop 2. The same way I can make the loop here. This time let's use the clockwise, anti-clockwise, doesn't matter. I'm using the clockwise. You choose your own direction. Now, you see, this is the positive terminal and this is the negative terminal here. And the loop is going from positive to negative. If it's going from positive to negative, you have to choose the negative here, the negative 15. Let's come back here one more time. Here, the current and the loop direction are the same for R2. If they are the same, you have to use the negative sign. But you have I2 times R2. Here again, they are exactly in the same direction. So what I have is I3 R times R3. They are in the same direction. You have to use negative sign. It's going from positive to negative. That's why I have the negative sign here. The current I2 and loop direction are parallel, negative sign. Current and the loop direction is parallel, negative sign. Okay. I have to find out the current through resistor R3, which is I3. I have to solve for I3. So what I'm going to do, this equation has I2 and I1. This has I2 and I3. So, but I did I3. How do I solve I3 now? So what I can do, from this equation, I can calculate I1 is equal to I3 minus I2. And I'm plugging, let's call this as a 1. The first equation here. I'm plugging 1 into, if I call this a 3, I'm plugging 1 into 3. Plugging equation 1 into 3. You just have to solve for because we need I3, so I'm getting rid of the other variable I1. So minus 15 minus I2 and R2 is, let's keep it R2 for now, minus just one second. Okay, I have to put into equation 2, not in 1, equation 2. Okay, I'm just plugging this into equation 1 here. The 10 plus I2 R2 minus I1. I1 is now I3 minus I2 times R1. This is equal to 0. This is R1. Now let's solve here a little bit. Simplify this equation now. 10 plus I2 R2 minus I3 R1 plus I2 R1. This is equal to 0. This implies 10 plus I2 R2 and I2 R1 we have together. And R1 is, what's the R1 value? 34 ohm. And R2 is 60 ohm. If I add them together, what I get? 94. So I get 94 times I2. This is R1. So R2, we have to add R2 and R1. So 94 times I2 minus R1 is 34. 34 I3. This is equal to 0. I'm just plugging in the values of R1, R2, and R3. You see, these two terms will be added together. R1 plus R2. If you see R1 plus R2, that is 94. And R1 is simply equal to 34. So this is my one equation. That's 4. Now let's plug in all the values into this equation 2. From this equation, what you see, equation 3. I should have plugged in here. It doesn't make a difference. So just plug in all the values here. Minus R2. What is the value of R2? 60. 60 times I2. What is the value of R3? 180. 180 times I3, this is equal to 0. 5. Now you have two equations. You just have to solve for the two equations. How do I solve it? I will just show you how to solve it. You can use the different calculators, or here for simplicity I'm going to use the one software called Symbolab. It just takes time, so you just type in here. Okay, so you have two equations here. So you have two equations. I'm just solving for these two equations. So just write down these two equations here. The first equation is 10 plus 94x minus 34y. This is equal to 0. And then you have minus 15 minus 60x minus 180y. This is equal to 0. Is equal to 0. And now hit the enter button, and it solves for you. It might look a little bit mixture here. So this is how I typed in all the equation. Okay, so once you typed in, this is your equation here. And once you type in, this is the solution you get. Okay, so what are the solution that I got? I3, the y is I3. I got I3 is equal to minus 27 divided by 632, and I got I2, which is equal to minus 77 divided by 632, and the unit is ampere. So this is the answer I got. And this tool is pretty simple to use it. You see, these are the two equations. The two equations I typed in, and it gives me the answer. All right. So here is the solutions. If I want to take a look, I will move this one to the other side, just for clarity.